All right, so today is it. This is your last day of notes in geometry. You made it. Today we're going to finish up by talking about pyramids, cones, and spheres. All right, so on this page of your notes, let's just real quick talk about the different parts of these shapes. A pyramid is going to have one base. Remember, our prisms and cylinders had two. So pyramids have one base, all right? And the other sides come to a point. And other sides come to a point. That point is called the vertex of your pyramid. All right. The sides of those triangles, and I do want you to notice that, well, let's me back up a minute. So here is my base, right? And then when you take the other sides and they all connect at that vertex, all right, you will notice that those sides going around are always triangles, right? Now, the crease of those triangles, that's called a lateral edge. But the face is called a lateral face. Okay, they're all faces. So the triangles are specifically lateral faces. All right, the bottom of that pyramid, of course, is our base with the capital B again, like we did yesterday. Okay. Of course, that base can change shapes. All right, this one kind of looks like a square, but it's, since we're not 100% sure, we would call this a rectangular pyramid. Again, it's rectangular, AR, pyramid. If it was a square, we would call it a square pyramid. If it's a triangle, it would be a triangular pyramid, all right, and so on and so on. So that base can change shapes, all right. I do want to point out with the lateral faces, all right, these are always triangles, no matter what the shape of the base is. Now, there's actually two heights in a pyramid, and we want to make sure that we get the right one. All right, all these lateral faces, there's going to be a height to those triangles, all right? And I'm actually not going to call it little h. This height right here is usually like a cursive L is used to represent that. And this is called the slant height. All right, so this is the actual height of the lateral face, slant height. Now you would need that height if you were doing surface area, okay? But we're not. The other thing I'm going to add is that that slant height would make a right angle with the base of the triangle, okay? So it is the height of that side, but it's called specifically the slant height. The height we need, I'm actually going to use a different color here, comes from the vertex and will make a right angle with the base. All right, this is the height we need. That's the height of the solid. So you want to make sure that you're coming from the vertex straight down so that it's perpendicular with the base. Okay, that's the height that we need. And I'll put of solid. All right, so a lot of parts to those pyramids. Let's look at a cone. All right, so a cone, of course, has a circle base, right? One base. That's a circle. And then, of course, comes to a point. And that point, once again, is our vertex. Here's our base. I'll write it out here. That's what it's pointing to. Capital B, that's the base. And then again, there's two heights. If you kind of follow this crease, what it looks like, although in a cone we really won't see that, this is that slant height. And they use that cursive lowercase l to represent that. The height we need is going to come straight down and be perpendicular with that base. That's the height we are looking for when we do volume today. Okay. And then a sphere, all right. You usually see this little arc drawn around it. This is actually what we call the great circle of a sphere. All right, kind of think of the equator of our planet. All right. And what we need is from the center going out, of course, we need the radius. That's what we're going to need for a sphere. But without the little arc and the dotted line going back, showing that great circle, it just looks like a circle. So we got to have it look like it's got some dimension to it. All right. So those are the parts. So let's talk about volume. Now, just because the way the notes are typed up, spheres following cylinder. So we'll start with the sphere today. Sphere has its own special formula, and it is, and mine's probably not the most clearest, it is 4/3 pi r cubed. That is the formula for volume of a sphere. And like we talked about, all you then need to know is what the radius is to throw into that formula. All right. So notice the example, though, that I gave you. All right, here's my great circle going around, but the length that they've given me is not a radius, it's the diameter. So the diameter is 26 feet. So the radius is going to be that cut in half. So it's going to be 13. We want to make sure we grab the right number. So simply volume is going to be 4/3 times pi times 13 cubed. And of course, I just remember that it is cubed because volume is always cubed, so that there'll be a cube in that formula. Now, when I type this in, lots of options. You could do 4 divided by 3 and then just keep doing times pi key times 13 raised to the 3rd power, or go across and do 4 times pi times 13 cubed, and then last divide by the 3. Up to you. And my calculator is telling me 9,202 point, I'll go out 2 places, 77, and then this would be feet, again, cubed, because it is volume. All right, 4/3 pi r cubed, pretty straightforward. All right, let's look at pyramids and cones. Now, with pyramids and cones, again, there's a very basic formula. All right, it is still area of the base times the height, but with pyramids, it's only 1/3. All right, the volume's only 1/3 of a prism. All right, so 1/3 area of the base times the height. So again, since the base can change, that big B is going to change. When I look at this, this tells me it's a square pyramid. Okay, so to find the area of a square, again, length times width is one of the ways to do it, and then times the height of the solid. And then notice instead of the 1/3 being out front, it's just divided by 3. Same thing, but it's nice to write it like this, and then in the calculator, you type it just like that. So for the parts, what do we need? We obviously need to know the length and the width of that square or rectangle base. All right. And then the height, remember, it goes from the vertex, has to come down to the center. That's the height, the capital H that we need. So in our example, all right, when I notice that this is a square pyramid, obviously the base is square, 11 and 11. All right, that's my length and my width. And then notice they're showing both the height of the solid and the slant height. Make sure you grab the right one. 8 is the one that's the height of the solid that we need, not the 10. So the volume is going to be 1/3, and then we're going to do 11 times 11 times the 8. So in my calculator, I'm going to do 11 times 11 times 8, and then divide that by 3, 322.67. This is meters cubed. A cone, notice, has the same base formula, 1/3 area of the base times the height. So this is also 1/3 of what a normal cylinder would be. All right. Area of the base, because it's a circle, is going to be pi r squared times the height of the solid, and then of course divide by 3. So I need to know the radius, and again, I need to know the height of the solid coming straight down. So in number 6, when I look at this, I've got my radius, and then you make sure you grab the right height. The 12 is your slant height. We need the height of the solid, which is the 10. So volume will be, all right, 1/3, and then I've got pi times 5 squared, and then times the 10. All right, so let the calculator do its magic. So 5 squared is 25 times 10 times pi. Divide all that by 3, 261 point. If I go out 2 places, that's going to round to 80. And this is inches cubed. Okay. So the sphere has its own formula, but when you're doing pyramids and cones, remember it's 1/3 the area of the base times the height. So just remember to divide that by 3. If you need any help, come see me. Enjoy your day.